Okay, today's lesson from section 6-7 on the quadratic formula. We will be able to solve quadratic equations and use quadratic equations in different style of word problems. But let's go and talk about where the quadratic formula comes from. So this is an example of the proof of the quadratic formula. When we say this, we're looking at, we know standard form of a quadratic is ax squared plus bx plus c. But after that, we learned when you complete the square, you should always have an a term that's 1. So first step is to go ahead and divide that a term throughout so that we get an a term of 1. When we do that, you can see the resulting equation. And let's simplify it a little. Now we have some fractional usage. You say, where are the numbers? Remember, a, b, and c are actually where the numbers are. And our next step was to move that constant to the other side. So we move it by subtracting. So I'm showing subtract a c over a value. From there, that leaves the fill in the blank part where we put blank on both sides. And if we do that, that blank represents that perfect square combination we have to find. And to do that, next step, we said you take half of the middle term and you square it. So half of b over a is b over 2a. Squared would be b squared over 4a squared. You can see that here. And we add that to both sides in the blank. From there, we need to simplify. So on the left-hand side, we just made that a perfect square, so let's write it that way. Now in that fraction, the b is obviously a perfect square, but the 4a squared, same thing. 4 is a perfect square, a squared is a perfect square. So when we take the square root of that, we get b over 2a. On the right-hand side here, it's not as easy to see, but we needed a common denominator. So on this fraction here, we had to multiply by 4a, both on the top and the bottom, to get the fractions to be the same. Because remember, you cannot add fractions without common denominators. So from there, we now need to take the square root of both sides because we're trying to get x by itself. And when we do, you can see we got square roots on both sides. The square root of a square is just that thing. So let's look. And that thing is x plus b over 2a. And we've got plus or minus the square root of b squared minus 4ac all over 2a. Last thing, to get x by itself, move that b over 2a to the other side, and lo and behold, take a good look at what we have. We have what is known as the quadratic formula. So x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. So notice that came from standard form, and we're going to show you how, if you can't do completing the square very well, then you have this option. And so let's find out what we need to do. Remember, when you're trying to find solutions to a quadratic is nothing more than a parabola. And so here's an example of it. You know, it has a low point. In this case, it's moving up. But that parabola's solutions are really just right there. Those places that the axis and the parabola cross, intersect. From there, we can say the solutions are the x-intercept. So if we can find those points where the parabola crosses the x-axis, we're good. Now, the solutions are also called the x-intercepts, the roots, or the zeros. So please make sure you take down all of these different words here, because they are all going to be used at different times. So if it says find the solutions of the quadratic, find the x-intercepts of the quadratic, find the roots of the quadratic, or even find the zeros of the quadratic, you know the process can be the same even though the direction might be asking for something different. So we're ready to find the solution. So using that quadratic formula, we can, instead of completing the square, we have just shown that we could take that quadratic and use the quadratic formula. So remember, a, b, and c are numbers. So here we go. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a is how we like to say it. And that needs to be memorized if it isn't, if you didn't bring it from geometry. Now, make sure your equation is in standard form, step 1. On the x-axis, the value of y is always considered 0. So we'll replace the f of x with a 0. So then our equation is ax squared plus bx plus c equals 0. We will identify a, b, and c. So in other words, identify what the numbers in those positions really are. Substitute those a, b, and c values into the quadratic formula. Go ahead and simplify. And as I say down here, watch out for square roots that are negative, because right now we don't have any way to simplify a negative square root. We would have to say that that quadratic has no solution. So moving forward, if we say which expression could you use to solve, look at this. The first thing you want to do is write the quadratic formula when you see a quadratic equation or expression. So here we will. Then you've got to start thinking, B, A, C. So identify A, B, and C next. So in your equation, ask yourself, what's A, what's B, and what's C? A is definitely 3, B is 2, C is 7. Now we want to substitute those values into the quadratic formula. So take a good look. A is 3, B is 2, C is 7. So we want to say opposite of B. Well, the opposite of B gives me a negative 2. So right now, if we're trying to choose without our devices going, those are gone. Opposite of B, plus or minus, B squared. Well, B still is that 2 value. So we now have gotten that, and we know that D is our solution. So just substituting correctly is a big thing. All right, so on this one, if we go through, we'd say A equals negative 3. B equals negative 6, C equals negative 7, and we would put the values right into the formula, if that is our equation, okay, and then do the math. Negative 3, negative 6, and 7. So look at this one. Which expression would you use to solve? Again, the same way. Opposite of B, so you start looking for that, what is that? It's definitely not that and not that. Plus or minus the square root of B squared. Gone. Answer. So obviously now we're going to have to do the math at some point and not just put the numbers in. Okay, look at this one. Opposite of B. So you start looking. What's the opposite of B? Plus or minus square root of B squared. So again, I think we have a value here. All right, solve by using quadratic formula. So here we go. A equals 1, B equals negative 5, C equals 6. Let's go and write into the formula. X equals the opposite of B, plus or minus the square root of B squared. I would always do that math when it's a simple number. Minus 4 times A times C, all over 2 times A. 2 times A is 2. So hit the square root first, do the multiplication. 4 times 1 times 6 is 24. So 25, take away 24, leaves us with the square root of 1, all over 2. Do the math. You're looking at 5 plus or minus 1, all over 2. Do the math again. 5 plus 1 is 6. 6 divided by 2 is 3. 5 minus 1 is 4. 4 divided by 2 is 2. So we're looking at two solutions, x equals 3, x equals 2. That means our parabola crosses the x-axis at 3 and 2. And there, if we graph it, we should be good. So look at our values again. 1, negative 5, negative 6. You can see our solutions, put them in. So based on that graph, just going back real quick one more time to look at it, what are our solutions? Where does it cross? If that's our graph, it crosses at negative 1 and positive 6. There it is. There's the math. Finish. On this one, be careful because you have that 9x squared minus 1. Let's go right to it. Without graphing, you want to think of this as A equals 9, B equals 0, and c equals negative 1. So when you do the math here, x equals the opposite of b, plus or minus b squared, minus 4 times a times c, all over 2a. 2 times a is 18. But you do the math up here and you get 4 times 9 is 36. 36 times negative 1 is negative 36. We get a 36. So we got a 0 plus or minus. And the square root of 36 is really just 6 all over 18. So do the math. 6 over 18 reduces to 1/3. And 0 minus 6 is a negative 6 over 18 is a negative 1/3. So we're getting two very small but accurate numbers on this one as our solutions. Same thing again. A would be 3, B would be negative 7, C would be 0. So do the quadratic formula and see which our answer is. We can reveal that in class. It's just practicing putting the numbers in, doing the number crunching. That's all it is. So here it is. A is 3. B is negative 7. C is 0. And so when you do the quadratic formula now, you will get x equals the opposite of b. So that would be 7 plus or minus the square root of b squared, 49, minus 4 times a times c, all over 2 times a. So look at that math and do the math. 49 take away 0 is 49. The square root of 49 is 7. So again, look at your work. You get x equals, if we do the top, we get 14 over 6. Reduce that by 2, 7/3. If you do 7 minus 7, you get 0. 0 divided by 6 is also, in lowest terms, 0. So you get two solutions on that one as well. They're not nice whole numbers, but they are solutions to the parabola. Remember, the solutions are the x-intercepts. So one last one. See what your result is. A equals 4, B equals 2, and C equals 5. X equals the opposite of B, negative 2. Plus or minus the square root of b squared. Go ahead and do that math right there. Make it a 4. Minus 4 times a times c, all over 2 times a. 2 times a would be an 8. Again, be careful with the math. We have to do 4 times 4 is 16. 16 times 5 is 80. But we've got 40 take away 80. So right now you know you're going to have, or not 40, 4 take away 80. You know you're going to have a negative 76 underneath that square root. As soon as you find a negative square root, you can stop your work if you're sure your arithmetic's correct, and you can write down no solution. Because right now we have no way to take a square root of a negative number. So you could get a 0 underneath, you could get a positive number underneath, you could get a negative number underneath, and it gives you your x-intercepts of your parabola. So with your previous experience with the quadratic formula and this new process, number crunching, that's what your work will be about. Bring any questions you have to class, and we will discuss any and all of them.